First question this week is sketch y equals x squared take 4x and y equals 6 take 3x on the same graph and find the area of the region between them. So I need to draw these on the same graph, therefore I'm going to start by looking for any points of intersection. Solve these simultaneously. X squared take 4x is equal to 6 take 3x because both those expressions are equal to y. It's a quadratic, so bring everything to the one side. Factorise. Multiply to negative 6 and add to negative 1, negative 3, positive 2. So there are 2 points of intersection, x equals 3 and x equals negative 2. I will need their y values, so I'll substitute them into one of these. I think the straight line will be easier. So if I substitute x equals 3, I get y equals 6 take 3 times 3, which is 6 take 9, negative 3. So that point of intersection is 3, negative 3. And if I sub the other value we got, which is negative 2, into here, the y is 6 take 3 times negative 2. 6 plus 6 is 12. So that second point of intersection is at negative 2, 12. The other thing I'm going to need is the vertex of the parabola. So that was y equals x squared take 4x. The x-intercepts are going to be at 0 and 4, so the vertex will be at x equals 2. And I'm going to sub that in. Y equals 2 squared take 4 times 2. 4 minus 8 is negative 4. So that point is 2, negative 4. And I've got that information now, so when I come to draw the graph, I'll be able to draw it properly. So firstly, I'm going to mark on the points of intersection. We've got here at 3, negative 3. We've got another one at negative 2, 12. And the other point that we found, just to help us draw the diagram, was the vertex of the parabola, and that was at 2, negative 4. So the parabola has x-intercepts 0 and 4, and we can draw that in. Okay, now the straight line is y equals 6 take 3x. So cutting at 6, I know it's got to go through this point and this point. Okay, so there's the graph, and we need to find the area of the region enclosed between those two graphs. So we can tell by looking at it that the region enclosed is this one here. And we're going to find the area of that algebraically, but there's a couple of clues we can take with us from the graph that we've sketched. Firstly, it's from negative 2 to 3. They're going to be our terminals because they're the x values between which we need the area. And also, the straight line is higher than the curve in the region that we're dealing with. Once they cross over, it reverses. Here the curve is higher than the line. But for us, for that region, the line is higher than the curve. So let's go on and find the area. So the area is the integral from negative 2 to 3. They were the x values of our points of intersection. Now the line was higher. So 6 3x goes first, and then we subtract the curve. X squared take 4x dx. Simplify. 6 take 3x, take x squared plus 4x. Keep simplifying. Negative x squared plus x plus 6. And then we need to integrate. So this is when we change our notation. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And 6 becomes 6x. Now substitute. Sub in the 3 first. Sub the 3 in here. 3 squared over 2. Sub the 3 in here. And then subtract and sub in the negative 2. So negative of negative 2 cubed over 3 plus negative 2 squared over 2. And I'll need to go to the next line. Plus 6 times negative 2. And that's all in that big bracket. And you can put that into your calculator. Simplify it a bit if you want to first. But when you put it into your calculator, you're going to get 125 over 6. So that's it. That's the area of the region between those two. You would expect to get a positive answer because we did the higher curve minus the lower curve, and the area of any given shape is always going to be positive.